Hello everyone. In the previous video we have seen how to measure one of the op-amp parameter, that is the input offset voltage. Now in today's video we are going to see how to measure the power supply rejection ratio. Before going into the concept, let us see what is the definition of power supply rejection ratio. So this power supply rejection ratio, it is simply defined as the ratio of change in input offset voltage to the change in power supply voltage that is produced by maintaining other power supply constant. Since we know that the op-amp has two power supplies, one is a positive power supply and other one is a negative power supply. Now what we have to do is, we have to kept one power supply, either positive or negative, should be constant, and the other power supply value should be changed in order to see if there is a change in the input offset voltage. So this change of input offset voltage divided by change of one power supply by maintaining other power supply constant, it is nothing but a power supply rejection ratio. Okay, this is the definition of power supply rejection ratio. Yes, in some cases we can call it as power supply sensitivity, that is PSV. Now let us see what is the practical circuit that is used in order to calculate the PSRR value. So it is a circuit that is used in order to measure the PSRR. As we know that the same circuit is used in order to calculate the input offset voltage, one of the op-amp parameter. Now what we have to do is, we have to repeat the same procedure while doing the input offset voltage. That is, first of all we have to kept the VCC and VE values and constant, and we have to change this potentiometer value in such a way that the output voltage value will be 0. So at that case we have to note down what is the value of VE and thereafter measure the value of VA by applying the voltage division rule. So that VA is nothing but 1 by 1K plus 1 into VE. This VA terminally we can call it as a input offset voltage. So this is how to measure the input offset voltage. First we have to maintain this condition. Next, what we will have to do is, we have to maintain one power supply constant and we have to change the other power supply. Now in this case I am maintaining the constant VEE supply. Okay, and here this VCC value will be variable, that is, here the VE value is always kept constant to minus 10 volts. Now this VCC value will changes to 10 volts to 9 volts. So whenever the VCC is changed to 10 volts to 9 volts, again this potentiometer is to be adjusted in such a way that in order to get the output voltage V0 value as 0. In that case, measure the value of VIOS, that is VE by 1000. So here this VIOS1 value is measured when VCC changes from 10 volts to 9 volts. Similarly, when VCC value is changed to 10 volts to 11 volts, again measure the value of VISO2 by repeating the same procedure. Now note down these values of VIOS1 and VIOS2 and simply substitute this formula. That is delta of VIOS by delta of VCC, that is VIOS2 by VIOS1 by 11 minus 9. So this PSRR value is VIOS2 minus VIOS by 2, which is given the value practically. Here what we have kept, we have to maintain the constant VE value, that is minus 10 volts. So this is the procedure for calculating the PSRR value by maintaining VE constant and VCC variable. Similarly, we can calculate the value of PSRR value by maintaining this VCC as constant and VE as variable. Repeat the same procedure, we will get the same value. So this is how to measure the op-amp parameter, that is power supply rejection ratio. So this is the concept is used, and we have all seen the measurement parameters of op-amp, that is PSRR, input offset voltage, input offset current, CMRR and output offset voltage. Okay, if you have any doubts, please comment in the comment section. Thank you.